helps.
So there are two environmental issues left for us to cover. So we've been talking about some environmental problems caused by human pollution, and we need to talk about two more. Let me just fix this projector. So, has anyone ever heard of the ozone layer?
Yes.
Oh, okay, good. So tell me something about it, Emily.
It's like a layer of gases that protects the Earth from the sun's UV.
Yeah, exactly. So it's a layer very, very high up in the atmosphere, at the top of our atmosphere. And the ozone layer filters out some of the sun's ultraviolet radiation. Now, what is ultraviolet radiation? What effects does it have on living things? David?
Burns the outer layer,
Outer layer.
skin.
Yeah, it can. The reason you get a sunburn when you're outside in the sun without sunscreen is because ultraviolet radiation damages our skin and leads to sunburns. And what else, Dan?
It sucks up water.
No,
No.
no, not UV radiation.
You get skin cancer.
Yeah, so as you, I'm sure, know, an increased exposure to ultraviolet radiation, increased number of sunburns, can increase the risk of skin cancer. But it not only affects humans, okay? Ultraviolet radiation also damages plants and animals as well. So the ozone layer helps protect us from that ultraviolet radiation. So what's the issue with ozone layer? Right?
Has a big hole in it.
Yeah, that it has been damaged. And it's been damaged by a type of pollution released by humans. And that type of pollution is called chlorofluorocarbons. That's one of the main reasons that the ozone layer has been made thinner. We call that ozone depletion over time. Chlorofluorocarbons are abbreviated CFCs. Chlorofluorocarbons used to be used extensively in all basically aerosol spray cans, can of spray paint, hairspray, things like that. The propellant in those cans used to be CFCs. And so you put some spray paint on a car, and as the propellant is also released with the paint, it goes up high in the atmosphere and actually destroyed the ozone layer. And so the accumulation of these ozone-destroying chemicals in the upper atmosphere led to the ozone layer becoming thinner and thinner, and eventually even developing a hole, especially over the South Pole, Antarctica.
Why the South Pole?
That's just where these gases tended to accumulate and damage the ozone layer. So this map shows some imaging of the ozone layer in 1979. You can see it was thinner in that area of the south, over the South Pole. By 2008, it had gotten much worse. And so the consequence of that, more ultraviolet radiation reaching the Earth leads to increased incidence of skin cancer, but it also disrupts ecosystems. Plankton in the ocean cannot tolerate high levels of ultraviolet radiation. So plankton in the ocean starts dying off, or its population starts decreasing. Plankton are the producers, the base of the whole ocean food web. So if you decrease the amount of plankton present, you're going to be disrupting that marine ecosystem, that ocean ecosystem. Now, the good news from ozone depletion standpoint is that in 1987, when scientists realized that this was becoming a problem, they had a meeting in Montreal, and the Montreal Protocol was enacted. Countries from all over the world met, and they agreed to limit the production and use of CFCs amongst a whole bunch of different countries. And we've decreased our use of CFCs extensively. They're no longer in aerosol cans. There's other propellants that are used that don't damage the ozone layer. There's still, CFCs are still used in like air conditioning units, refrigerators, car air conditioners, some uses, but much, much less than they were used. And what we've seen since that that the ozone layer has started to improve the damage to the ozone layer. The damage has decreased, and it's possible the ozone layer can start to repair itself. But again, like we talked about with acid precipitation, it can't just be one country taking measures to reduce CFCs, because these gases don't respect the borders of individual countries. This is a global issue. So it takes things like an agreement, a treaty from multiple countries to really address the problem in a significant way. Well, that's an example of how that can work. That countries got together and they helped improve upon an environmental problem. So that's the ozone depletion. Our last environmental issue that we'll talk about is climate change, also called what? Global warming. Really, the more modern term is climate change. Because global warming is a little bit misleading, because not all parts of the earth will warm at the same rate, and the issue is not just about the earth getting warmer, it's about other changes that happen to climate and weather as a result of this. So, our earth is getting warmer. We know that. Okay, we have historical data. We go back and look at the temperature of the earth, and it's progressively getting warmer. And so, what's causing this? Why is the earth getting warmer? How?
Is it because of like the pollution in the ozone layer and then it's more like sunlight's getting in?
Not quite. It is due to pollution, but it is not really related at all to the ozone depletion. So those two issues, many people will confuse those two issues. They're really pretty much separate problems. More ultraviolet radiation getting through the ozone layer is not a big factor in climate change. So it is due to pollution. What type of pollution leads to climate change? Jeremy? Burning fossil fuels, which there's a specific gas released. David? Yeah, carbon dioxide is one of the main greenhouse gases. We call these greenhouse gases that lead to the warming of the earth. There's many of them, but carbon dioxide is one we really focus on usually. You can imagine carbon dioxide in the atmosphere acting almost like a blanket. It traps the Earth's heat in. And the more carbon dioxide you add, the thicker that blanket, the warmer it keeps the Earth. And most of that carbon dioxide comes from burning of fossil fuels. And I'll show you a graph in a minute that'll show you CO2 levels. But CO2 levels have increased drastically since the 1850s.
I know,
Connect it with social studies.
I know.
Mr. Inman would be proud.
Industrial revolution.
Yeah, it's due to the Industrial Revolution.
Yeah,
Tell me about that. Somebody else who's going to raise their hand. David, tell me about the Industrial Revolution.
I just need the answer.
Okay. Reagan?
Running and tools were replaced with machines.
Yeah, hand tools were replaced by machines. Okay, why does that lead to increases in carbon dioxide? Emily?
because they started like burning fossil fuels.
Yeah, that to power that machinery that was being used required fuel. And the fuel that was available was fossil fuels, coal mainly. Also oil and natural gas, but mainly coal. And burning of fossil fuels releases carbon dioxide. The consequences are significant. And there's a whole bunch you could list, and I'll list a few. One is that as the Earth gets warmer, ice at the Earth's poles in northern and southern areas begins to melt. And as that ice melts, the ice that's over land, the water runs into the oceans and increases sea level.
So is eventually the sea going to like shrink countries?
Yes, and I'll show you some maps in a few minutes. As the Earth gets warmer, the ocean water becomes warmer. And Warm water in the oceans is the energy that supplies storms, tropical storms, hurricanes. We've seen that in the past, in recent history, we've had more and more severe weather events. More class 4 and 5 hurricanes have been developed. And scientists believe that that's due to warmer ocean waters, due to the warming of the earth. Habitats change. Obviously, all the species on Earth are adapted to certain conditions. They've evolved to live in certain climates. As the weather changes, as climate changes and warms, well, that changes the habitats. And some organisms might, the range of where they can live might expand. Some organisms might shrink. Can you think of an organism we talked about that only can live in relatively warm climates? This is an organism we would not want its range to expand. True?
Extremophiles?
Well, we're not talking that extreme. They do live in extreme conditions. I'm thinking something else.
Snakes.
You know?
Mosquitoes?
Yes. So the mosquitoes specifically that transmit what? Malaria. Why don't we have an issue with malaria in New York State?
Because it's too cold.
Too cold, right? Those mosquitoes, Anopheles gambiae mosquitoes that transmit malaria, they can't live here. And the parasite that causes malaria needs warm conditions to complete its life cycle. But if the earth on a whole becomes warmer, the areas where those mosquitoes can live expands. And the areas where that parasite can go through its life cycle expands. And therefore, malaria can spread. Oceans become more acidic. Carbon dioxide, when it dissolves in the ocean water, makes them more acidic. And this increase in ocean acidity can have negative effects on ecosystems, especially things like coral reefs. Have you heard that there's an issue with coral reefs dying off? And scientists think a large factor in that is climate change, ocean acidification. So the process by which the earth gets warmer, it's called the greenhouse effect. Okay? This little video will just explain a little bit about climate. Yeah, it's only 5 minutes. It's not the Bill Nye you remember. It's not like boo.
Despite the noise about uncertainty in the political arena,
Warming will actually save lives, not endanger them.
Do I believe scientists? No!
the fundamentals of climate change have been understood by scientists for decades. To start with, there are naturally occurring gases, such as carbon dioxide and methane in the Earth's atmosphere. In themselves, they aren't bad. In fact, we need them in limited quantities to keep our atmosphere at just the right temperature for life as we know it to exist on Earth. But if we produce an excess of these gases, as we have, the temperature rises, as it has. If you want, you can replicate this effect yourself in a simple lab experiment. Here's how. Take two identical bottles and set them side by side. Put a thermometer in each bottle and seal them. Then run a hose from a source of CO2 into one of the bottles. Shine two heat lamps of equal intensity at equal distance onto each one. Within minutes, you will see the temperature of the bottle with the carbon dioxide in it rising faster and higher. The bottles are like our atmosphere. The lamps are like our sun. Most of the solar radiation reaching the Earth is absorbed by the surface and atmosphere, which in turn radiates energy out towards space as infrared energy, heat. Most of the heat energy from the surface is then absorbed by the greenhouse gases in the atmosphere and radiated back down toward the surface. The more greenhouse gases we create, the more heat is absorbed and sent back toward the surface to cause further warming. This recycled heat does more than bump up the thermometer. Warm air has the capacity to hold more moisture, and water vapor is itself a greenhouse gas, so there's even more warmth. which means the planet's entire hydrological cycle, the water cycle, is affected. More evaporation, more precipitation, more extremes in general. For nearly 1 million years, the CO2 content of the atmosphere moved within a natural bandwidth. But during the Industrial Revolution, humans started burning fossil fuels in increasingly large amounts. In fact, now, that's around 7 billion of us, rely on carbon-based fuels for 85% of our energy. Humans currently produce around 35 billion tons of carbon dioxide every year. About 55% of that is absorbed by the ocean, land, and vegetation, while the rest remains in the atmosphere. Most of that excess comes from burning fossil fuels. And more than half of the emissions come from power plants and factories, while about a third comes from our various forms of transportation. If we continue the current trajectory, by the time our children reach middle age, the levels of atmospheric CO2 will reach twice that of our planet's long-time natural levels. That is why we're already seeing the temperature increase, and we're already seeing the consequences. 4% more moisture in the atmosphere above the ocean is enough to transition to a new normal. Dramatic weather events, floods, storms, droughts, fires, they're all happening at a frequency and intensity we've never experienced throughout human history. In other words, climate change. We've set this chain in motion, but the truly cataclysmic changes can be prevented if we act now.
Carbon dioxide is not a harmful gas, it is a harmless gas.
The first step is to separate fact from fiction. This climate science is no longer a matter of opinion, politics, or dogma. So let's not let a few dirty energy companies fool us or slow us down. There are now increasing numbers of affordable, clean tech energy sources, all available to us in limitless supply. By embracing them, we will create jobs and improve the economy. The current climate crisis is reality. We can't wish it away. What we can do is cease the debate and the denial and move on to solutions together.
All right. So you see just sort of the basics of climate change there. So this little animation shows how temperatures changed on Earth over the past 150 years or so. So getting farther towards the edge indicates warmer conditions. It'll start over. So you see 1850 temperature increasing as time goes on, up to an increase in almost 1.5 degrees Celsius.
Do any keys run off in the final review?
The packet?
Yeah.
Yeah, I was going to just copy. You make some copies for me?
Well,
Are you
oh,
copying?
you have.
And so if we look at why that's the case, we look here at historic carbon dioxide levels. This is over the last 400,000 years or so. We see that there's a cycle, right? Carbon dioxide naturally fluctuates. And some, over a long period of time, 50, 60,000 years. Sometimes carbon dioxide levels are relatively low. Other times they rise up and continue. What do you think it meant when the carbon dioxide levels on Earth were very low?
Ice age.
Yeah, there were colder conditions, ice ages. We know that historically the Earth has gone through periods of cooling and warming, okay, and that continued. However, once we look at modern times, that normal cycle that's been going on for 500,000 years, all of a sudden kind of breaks here. And carbon dioxide levels don't continue in that pattern. They continue to rise, and they're even higher than that today. Okay? So carbon dioxide levels hadn't been this high, this dotted line, since 650,000 years ago, and they're well above that now. So this increase in carbon dioxide is what leads to the graph we saw on the other page, increase in temperature. Here's another explanation for climate change. Is shining into the car. The sun's energy can get through the glass, okay, and heats up the inside of the car. However, the heat energy cannot escape. It's trapped by the windows. So the car gets hotter and hotter. That's how a greenhouse works. And that's how carbon dioxide acts in the atmosphere. Allows the sun's energy in and then traps the heat close to the Earth. And we can see effects of this throughout the world. Like we said, Glaciers are one area in which the effects are very obvious. So here, this is not a glacier. This is sea ice, ice at the North Pole, and that ice melts in the summer and gets very smaller every summer and then gets thicker in the winter. This shows the sea ice minimum, which is the summer sea ice at the North Pole. In 1979, you could see basically no free water passage here in this area. In 2005, we have much more free ice in the summer in the Arctic, okay, because that ice is melting, and that's even worse today. These are glaciers. Glaciers are sheets of ice that are on top of land. And this is the picture of a glacier taken in 1928. And then this is the same exact picture, same exact viewpoint in 2004. Obviously, all of this ice has melted. The glaciers receded back up into the mountains, and then it's left land and a lake and so forth. Okay, so we can actually see these glaciers receding and melting over time. This is a map of Greenland. Greenland's actually covered in ice usually. And so this is in 1992, okay, the ice versus land, and that's all melting. The surface is melting in those orange areas. 2002, again, 10 years later, it's gotten even worse. The issue is that if we continue on the path we are on, and carbon dioxide levels continue to increase, if all of the ice in Greenland and Antarctica were to melt, it would be huge quantities of water going into the ocean. Okay? And that would cause an extreme rise in sea level. And so that extreme rise in sea level, so this is worst case scenario. This is sort of if we don't do anything really to moderate and reduce our carbon dioxide use, which it's not definite that we are going to do anything. So this is, the blue is the current coastline of the southeast United States. Obviously, you can see Florida there. If all of that ice were to melt, Florida is basically gone. Florida is a series of small islands. All of the east coast of the United States has receded significantly. And in those areas, what's along the coast usually? Cities. Think about cities you may have visited. Boston, New York City, Myrtle Beach, Charleston, Atlanta, okay, Miami, Fort Lauderdale, New Orleans. People settle on the coastal areas. It's great for transport, great for trade, it's nice to be near the beach, and so those cities would be gone in this scenario. And if you look throughout the world, it's not obviously just the United States. Again, you see changes in the coastline, North America, you can see South America, Australia, Antarctica. This is Antarctica. You probably recognize the shape without the ice. Okay. And so that's obviously a problem because we have huge populations of people that live in coastal areas. Some countries basically would be gone. Think about like a country, for example, Indonesia, where you have hundreds of millions of people living on a series of small islands. Okay? Island nations are in big trouble if sea level rises to this extent. And so there are attempts worldwide to help regulate carbon dioxide emissions, but it's not easy because fossil fuels are cheap. There's a lot of money in fossil fuels. There's huge corporations that make money by selling fossil fuels, by pumping oil out of the ground, by mining coal and selling it. And so those industries have no real incentive to reduce our amount of fossil fuels that we're burning. And so it takes cooperation, again, like these other issues, from countries throughout the world. There was an agreement, there's been several agreements. One was signed in Kyoto, a global agreement to reduce carbon dioxide emissions. There was one in Paris more recently. And every country but one, I believe, Syria, was a member of this Paris Accord to limit our carbon dioxide emissions. And so countries were getting together, at least taking some steps to limit that. In the past year and a half, the United States has now pulled out of the Paris Treaty and taken our support for that away. Some people, so the science is clear. Global warming is happening. It's being caused by humans releasing carbon dioxide. However, there are some people that will try to make an argument that humans are not causing it, or that scientists disagree about it. They do not disagree. Scientists are very clear climate change is happening due to carbon dioxide being released by humans. But some people try to confuse the issue by bringing up sort of these incorrect facts. David?
But isn't all these like islands around? Wouldn't America be able to build a World Cup?
What island nations are you worried about?
Trinidad and Tobago?
I guess.
With the coastline, would it be like gradually flooding cities or like right?
No, it would be gradual. Well, I mean, here's what happened. The coastline would increase, and that would be gradual. Because like the melting of all this ice, what I'm telling you, this worst case kind of scenario, doesn't happen in 5 or 10 years. It happens in hundreds of years, slowly, gradually. But as it happens, you know, you also have all the other effects of climate change. Storms become worse. You know, disease spreads, ocean levels rise, areas get flooded, and so it sort of builds up over time. All right. Any questions about any of our environmental issues that we've discussed?